Hello, this is Captain Chaudhary. Today I'm going to speak about a meteorological phenomenon called Ekman's transportation. We are going to understand that how this spiral must be happening. What is the theory behind it? Who discovered it? Well, we are going to specifically talk about the upwelling on the western coast of South America and Africa. So what is that happens on the east coast so that there's a lot of upwelling. That means the water from underneath comes to surface. Now basically everything is dependent on conservation of mass. If a mass is shifted from one place to other place, that mass must be replenished from the other areas, and that is what is upwelling that happens on the western coast of Africa and South America. Now before we do that, let us try and understand some meteorological terms like Coriolis effect. What is this Coriolis effect? Coriolis effect is also called a turntable effect. Like if the wind is blowing in a certain direction in northern hemisphere, it will have tendency to turn to its right, and in southern hemisphere tendency to turn to its left. And same thing happens to the water body also, water current also. Suppose we divide the ocean body in different horizontal layers, and suppose a layer of current moves in a certain direction, the next layer will have a smaller magnitude and a slightly deviated direction, slight deviation to the right because of Coriolis, and the next layer will further turn to right and will reduce in the dimensions. By the time you are about 100 meters down, the direction is almost reverse and the magnitude is absolutely diminished. This is called Ekman's spiral. Reverse thing will happen in southern hemisphere, and let's come to our specific topic, like what happens, how the upwelling takes place on the western coast of South America and Africa. Now let us understand what are these trade winds. Trade winds are easterlies. Easterly means say northern hemisphere they are either easterly or northeasterly, and in southern hemisphere they are easterly or southeasterly. Now these winds, they blow towards the equator. Naturally, equator has got a low pressure belt, and these winds, they come from about 30 degrees north and 30 degrees south. So close to the West Africa or close to the western coast of South America, you find these trade winds are kind of southeasterly in direction. Now when the wind is consistently blowing over an area, say for example southeasterly wind, adjacent to the West African or West South American coast, it should give rise to wind drift current in northwesterly direction, but it does not happen so. Actually, you may say that the first 10 meter of the layer, that moves along the wind is because of Coriolis effect, deviated to the left in southern hemisphere, to the right in northern hemisphere. So the wind drift current is not exactly downwind. The wind drift current, say for example, will be deviated by about approximately 45 degrees to the left in southern hemisphere, right? So if the top layer is going in a certain direction, a layer, if you consider next 10 meter of the layer, then it will be slightly deviated to the left, and it continues till about say 100 meters, whereby the direction is almost reversed. So suppose we say that the wind is blowing along this coast, right? The wind is southeasterly. It does not mean that the northwesterly current will be generated. The current that is generated, that is the wind drift current, will be in a direction deviated to the west. But if we look at the vertical column, and if we consider say 100 meters, if the top layer moves in this direction, a layer which is 10 meters below will be slightly deviated to the left and reduced in magnitude, and this continues. The turning and reduction in magnitude continues, so that by the time you are about 100 meter down, your direction is almost reversed and your magnitude is totally diminished. But this does not have an effect of movement of the water downwind. It has, because of the integrated effect of all these currents, the net effect, the integrated effect is a big mass of water moves in a direction perpendicular to the direction of the wind on the left side in southern hemisphere and on the right side in northern hemisphere. That's because of the Coriolis effect. This phenomenon was first noted by Fridtjof Nansen, who recorded the ice transport appear to occur at an angle to the wind direction during his Arctic expedition. That was in the year 1890. His student, the Swedish oceanographer Sven W. Ekman, was the first person to physically explain the process, and that is the reason this particular phenomenon is known after Ekman, and we call it Ekman's transportation. Now, Ekman's suction causes upwelling, and this, I told you, has got a great biogeochemical effect on Earth's oceans. Upwelling carries nutrient-rich and cold deep sea water to the euphotic zone, promoting phytoplankton blooms. Areas of upwelling leads to promotion of fisheries. In fact, nearly half of the world's fish catch comes from these areas of upwelling.